Hi and welcome to Geeks for Geeks. Can I have a quick plus one in the chat if I'm visible as well as equally audible? Then we would quickly move forward. So let me just turn on my preview screen. So that I can monitor all the comments. Hey, hey BRK, how are you? Okay, thanks a lot BRK. Hi Shivansh, how are you? Hi Shalendra, hi Kundan Agarwal. So I would be replying to everyone chats. Okay, so I'm clearly visible as well as equally audible. Long time I'm back with the live stream. Okay, so how was the contest for you? May I know a quick feedback? How many of you were able to solve? This time, according to me, the first problem was very easy. So the first, so yeah. So th- this time the first problem was on a bit easier level. The second problem was a kind of difficult if the constraints were tight. But as the constraints were loose, so you can move forward with the brute force also. So second was a kind of implementation problem, and the third one was a little bit difficult problem. Okay, on what way it is difficult, on what scenarios it covers, I won't be revealing it now. Rather, I would be following the intuition and I would be moving forward towards the last. Okay. Hi, Devapriya Rajgupta, how are you? Okay, so can we start quickly? So let me see. Quickly like the video if possible. Quickly like the video. It just takes a matter of seconds. Quickly like the video, and then we would be moving forward with after a time frame of 1 minute. Okay, we would be starting off after a time frame of 1 minute itself. After the time elapsed is 1 minute, we would be moving forward. So now let's talk about the first problem. The first the first problem was a little bit easy. It was a variation of the prefix sum technique. Then the second problem was searchable and it was Googleable. But even if you don't Google it, it would be easy. Fair enough. Let's see. Okay, we have 31 seconds already consumed. So you can ask me anything. How was the problem for you? Okay, Michael was able to solve one out of the three problems. Yeah, that is also fine. How many of you were able to solve at least one in the contest? May I know? How many of you were there? Okay, fair enough. Let us proceed back. So let us move to the very first problem of today, that is equal left and right subarray sum. But before that, in the question itself, we are asked about subarray. So let us first learn about subarray. Subarray. The next thing we would do is subsequence, because subsequence is needed in the next problem itself. Okay, fair enough. So let us first do the subarray thing. So, and the next is subset. These are the three things that needs to be understood, and you would kind of face these all three terms a lot if you are preparing for placement or competitive programming. So you need to be very much familiar with the differences in between them. So the differences can be well understood by making a diagram of a person. Okay, so what I claim is subarray can be understood that we can take only one part from the person. So if we take one part from the person, either we would take the mouth, or either we would take the head, or either we would take the hands, or either we would take the legs. So only one part can be taken. So let us take an array also for an example 1, 2, 3, 4, and 5. If we are taking an array, then the examples of subarray are 1, 2, and 3. The next subarray example can be 2, 3, and 5. The next subarray example can be 2, 3, 4, and 5. These are all subarray examples. The next few things which are not an example of subarray is that we take two parts of it. Okay, like we take this part and this part. That is 1, 3, 4, 5. Okay, then we take this part and then we take this part. That is 1, 2, and 4. So these are not an example of subarray. So basically, you can tell that subarray is a contiguous part of the array. But in simple part, what you can do is wherever you are making the notes, just write subarray, subsequence, and subset. Draw the diagram of a human, just a pencil diagram, and then you can just write one part. So it can be well understood that you can just take one part from the human being. Okay, either the whole of it, either the legs, either the mouth. So am I clear till this point or not? Quickly tell me if this subarray thing is understood or not. Quickly send me a 1 in the chat if this thing is understood. Then we move forward to the subsequence. So subsequence, we can tell the definition as multiple parts in order. Okay, multiple part in order. So you can take the head of it, you can take the neck of it, you can take the legs of it, but you can't change the ordering. Okay, you can't change the ordering. In this way, 1, 3, 4, and 5 and 1, 2, and 4 are examples of subsequence, but 3, 1, and 2 and then 4, 1, and 3 is not an example of a subsequence. Okay, so you can just write the things that I am encircling. One part, multiple parts in order. Okay, now the last part is the same. So I would just say same as subsequence. The only difference is that an empty set also includes. Empty also includes. Okay. How is the 2, 3, 5 combination subarray? Okay, sorry. Extremely sorry about it. Sorry. I mistakenly wrote. Sorry. This can't be. Sorry. I'm extremely sorry for that. I was just trying to cover three things in a little bit pace. That is why I took all of this. I'm extremely sorry for this. Okay, 2, 3, 5. Yeah, I'm extremely sorry, Chandu and Devapriya. I'm extremely sorry for this. Actually, I was trying to cover three things. Just only subarray is required. But what I thought is just the definition of subarray, and then you would understand the definition of subsequence other day and subset other day would confuse you that what is the difference in between all of them. So I just tried to make everything at one place and tried to make it as concise as possible. That is the reason. Sorry, I missed it. Okay, so three things are clear or not? So subarray, you can only take one part of a human being. Either you can take the face, either you can take the chest, either you can take the legs or the whole human being. Subsequence, you can take multiple parts, but you should maintain the ordering. Subsequence is the same, but an empty is also included. Okay, so quickly tell me if this things is clear to you or not. Quickly tell me. Just send me a quick one. I would wait for the next 1 minute because this is absolutely very important. Then we would move back to the question that we were discussing. So we would again wait for the time frame of 1 minute. If you're watching the recording, move past the 1 minute and then we would again. Quickly send me a 1 if I'm clear. Thanks a lot, Himanshu. Thanks a lot, Michael. Thanks a lot, Ankit. Ankit is back after a long time, or I am back after a long time. What is the reason? I still remember your name, Ankit. चलो अच्छा लगा ना? चलो लाइक करो सब लाइक करो वीडियो तो। बस 3 लाइक है। quickly like the video. There are only 3 likes at the moment. Quickly like the video, please. Okay, let's move forward. Okay, let's move forward. Sorry, let's move forward with this. So you are given an array of n positive numbers. The task is to find the first index in the array such that the sum of the element before it is equal to the sum of the element after it. So even I can have skipped the this subarray thing, but I still wanted to explain it. Now what it is saying is, suppose we have A1, A2, A3, A4, A5 and A6, and it is telling that the first index in which, suppose this is the index, then A1 plus A2 should be equal to A4 plus A5 plus A6. So the sum of the elements before it and the sum of the elements after it, they should have the same sum, and the first index where we are getting this would be the point where this will be true itself. Okay, you're most welcome, Ankit. Okay, fair enough. This is the question. Now let us start evaluating the sample test case. थोड़ा इरेजर बड़ा कर लेते, बहुत छोटा हो गया. Okay, fair enough. We would increase the size of the sample test case, make it go up, and now we would start the iteration. ये भी हटाओ, ये भी हटाओ, ये भी हटाओ, जल्दी जल्दी हटाओ. Okay, now we would be trying to compute for this one. If this is the scenario, then for the index 1, so we are told that the indexing is what? The indexing is one index. So let us do for every index. Okay, so if this is one index, this is 2, this is 3, this is 4, this is 5. So if we are doing for one index, then the elements on the left, I would just draw a line over here. Yeah, so the element, this is for left, so I will just write here left. So just write here left, and I would write here right. So if we are on the first index, then the elements are 0. If we are moving on the right index, then ignoring that index because we are standing at this position. So before there are no elements, so I have just wrote 0. After that would be 3 plus 5 plus 2 plus 2. These all elements. Okay, 3, 5, 2 plus 2. That is definitely not equal to this. So 5 plus 2, 7, 7 plus 2, 9, 9 plus 3, 12. So 0 is not equal to 12. So the output shouldn't be equal to 1. Then let's move to the next index. That is the index 2. If we go to the first index, then these elements, that is 1. So we go to 1. And these all elements, that is 5 plus 2 plus 2. So 5 plus 2 plus 2 is equals to 9. So 1 is not equal to 9. Okay. Then we move forward to the third index. Okay. Then at the third index, we have 1 plus 3. So we would have 1 plus 3, that is equal to 4. Then we go to the next two indexes, that is 2 plus 2. So we would have 2 plus 2, that is 4 itself. That is why they both are same. So the first index where we encountered this is 3. That is why the output to this is 3 itself. Okay. Quickly send me a 1 if you have understood this question. Then I can move on to the explanation part. Else I would again do a dry run and I would explain you the question again. Quickly tell me. So what I did was, I just took up, I will just start the timer again. Okay, fair enough. So what I did was, I took up the index, then I calculated the sum before it and calculated the sum after it. Just wrote left and right. Then I kept the sum at this side and this side. Then I tallied it. If they are same in the first index where they are same, that means that that is the correct answer. Okay, thanks a lot, Michael. Thanks a lot, Shomesh. What about Chandu and all? Chandu, Ankit and all? Okay, many people are following up. Thanks a lot, Devapriya. Thanks a lot, Sudha and all. Okay, so I don't think a buffer of 1 minute is required. A buffer of 40 seconds is more than enough, I think. Okay, so I would be waiting this. Okay, fair enough, we did this. Now the first brute force approach we can think of is to consider all cases. Consider all indexes. Now to consider all index, what we can do is, suppose we are at the index 0. We are at the index 0. Then we would calculate the sum from 0. Suppose we have a1, a2, a3, a4, a5 and a6. And if the current index is 3, then we would go from a1 to a2 and we would again go from a4 to a5. Now the indexing would be in 0. So this would be 0, 1, 2, 3, 4 and 5. So if we are on the index 2, then that would be from 0 till, suppose this is I, till I minus 1. And in this part it would be I plus 1 till n minus 1 because it is one index. Okay. What if the array size is more than 20? Then we have to compare it from the start. Yes, if the array size is more than 20, then we have to compare it from the start. Size is not the matter here. Whatever be the size, this way would be the same. Size is not an issue here, because if the number of element is just 3 itself, then also the procedure would be same. This side and this side. If the number of elements are 1, then also the procedure would be same, this side plus this side. If the number of elements is again this, then this side plus this side. Again, the procedure would remain same irrespective of the size. The size make no difference in this. Okay, well understood? Okay. Okay, fair enough. Now, what we would do is, we would start the brute force implementation of this. So we would go to the sublime text. This is the very simple thing. What we would do is, we would start implementing the normal. Okay. So now, suppose we have the array A of n. Okay, and then we would declare n also int n. So we have the array and we have the size also. Okay. Now what we would do is, we would start a for loop. Int I is equals to 0, I is less than n, and I is 1. Okay. Now we need 2 loops for each index. Okay, we need 2 loops for each index. One loop to go on the right hand side, one loop to go on the left hand side. So what we need to do is, we need to go, what we saw, that we need to go from 0 till I minus 1. So we would do the same. So int left is equals to 0 and left is less than equal to I minus 1 and left plus plus. Okay, and this would give me the left sum. So I would just write here int ls is equals to 0 and rs is equals to 0. That is left sum and right sum. Now what we would do is, left sum is equals to left sum plus a of lsm. Okay. Now we have successfully completed the left sum. Now we need to think of the right sum. In the right sum, we need to go from I plus 1 because we don't need to consider that I. So I plus 1 till n minus 1 because the last element is n. Last element is n minus 1. So what we do is int r is equals to I plus 1. Okay. And r is less than equal to n minus 1 and r plus plus. Now right sum plus equals to a of y. Now this is the shorthand for writing rs equals to, so this is equivalent to writing rs is equals to rs plus a of r. This is just a shorthand implementation of this. Okay, fair enough. Now if both are same, if ls is equals to rs, then what we need to do is, we need to do cout I plus 1 because we need one index. But here in the for loop, we would do 0 indexing. So in reality, we would get the 1 indexing thing. Okay. Then what we would do is we would, suppose we found the first. So we need to report only one index. That is why we would break from this point. Okay. Now, am I clear with this implementation? Send me a quick one in the chat. Ramkrishnan Dikshit, I'm still waiting for the reply. Is your query answered or not? I want a feedback from your side. Okay. Now, in this scenario, what needs to be done is we need to be for each index. So for one index, we are going on all the elements left side and n side. So left side, all the elements. So suppose the number of element is equals to n. Okay, n. So from 0 till I, we have compared I elements. Okay, I elements, and we are again comparing I plus 1 to n minus 1. Okay, so basically we are again doing, so for each index we are comparing all the other elements. So we can safely say for one index we are doing n minus 1 operation. So now for n index, we would be doing n multiplied by n minus 1, that is n square minus n, and if you take the upper bound, that is big O of n square. Why? Because you could have ignored the constant at this place only. That is why we get to the conclusion that big O of n square is the time complexity of the solution. So now please see this with utmost care. So now what is the range of n? Okay, our solution is having n square. The range of n is 10 to the power 6. Okay, range of n is 10 to the power 6. Say this, I won't be doing for every question like this. Okay, so we saw that the time complexity of our solution is big of n square. So 10 to the power 6 multiplied by 10 to the power 6 in the worst scenario. So we would be doing 10 to the power 12 operation. So if we are doing 10 to the power 12 operation, and in 1 second we are provided with 10 to the power 8 operation. So 10 to the power 12 is much greater than 10 to the power 8, which is allowed. So we would definitely get a TLE even before implementing this. So we know that we will be getting a time limit exceeded if we get to implement this. We need to return the index value. Index value starts from 1. Yeah, index value starts from 1. So that is why whenever I got the index value, I just added to 1. Okay. That is why we would get a TLE. Send me a quick 1 in the chat if you are clear that why we are getting a time limit exceeded. So now let us see what we want. Okay, let us see what we want. Okay. Alright. So let us see what we want. A1, A2, A3, A4, A5. Now there are 2 steps involved in this. First, we go and consider each index. Consider each index. And in consideration of each index, what we are doing is we are iterating over all these elements. That is what is taking time. So sum from 0 till I minus 1 and sum from I plus 1 till n minus 1. We need the sum of these two. So considering each index, if we can do these things in constant time, then we can say that considering each index, so for each index consideration we are doing constant operation. So we would be doing big of n operation, so we can pass, because 10 to the power 6 is less than 10 to the power 8. So definitely we would be getting an AC if we are able to do this. What is 10 to the power 8? So see, this is a known fact that the online compilers allow us to do 10 to the power 8 operation in 1 second. Okay, that is already a given fact. This is how we would calculate. But in Geeks for Geeks, you are also given a thing known as expected time complexity. So is this thing given here, expected time complexity? No, but in most of the problems you would find that you are given an expected time complexity. But even if you're not given the expected time complexity, you can access it, you can have TLE or not. Because in 1 second you can perform only 10 to the power 8 operation. And the allowed number of second is still 1 to 10 to 1 to 5 seconds. Okay, ट्रांसलेटिंग द सेम इन हिंदी इज, सपोज क्या होता है ना, 1 से 5 सेकंड तक ही दिया जाता है. अब हर एक सेकंड में एक फिक्स नंबर ऑफ ऑपरेशन भी दे दिया गया है कि 10 टू द पावर 8 ऑपरेशन ही कर सकते हैं. अब हम लोग अपना ऑपरेशन कैलकुलेट करते हैं. अगर वो 10 टू द पावर 8 से ज्यादा होता है देन वी डोंट डू इट, और वी नो दैट वी वुड गेट अ TLE. Before even implementing, we can just calculate the number of operation and we can tell that if we would get a TLE or not. Fair enough? We would be moving forward with this. So now, whenever we know that we want the sum from this point to this point in an array which is static. What is static? That the values of the array is not changing. So now the need of the hour is sum in a static sum, range sum in a static array. What is static array? The array values do not change. Okay, so whenever we want range sum in a static update with no updation, then we should think about something known as prefix sum. Why? Because it would tell us the idea of this. So now, what is basically a prefix sum? The prefix sum is an idea to calculate the sum from a particular range. Okay, why it is needed? I have told you to do it in less time complexity. What it is all about? It allows us to answer queries in the sum with less than big of n, that is constant. Now, how to do it prefix sum? Suppose we have the given array as, what was the given array? So the given idea is this. Okay, so now what can be the prefix sum is? The prefix sum tells us that the first element should be copied. There are different implementation too, but I am moving forward with my implementation. The first element is copied. Now from the second element, what we need to do is, I will just copy the first element. Yeah. For the second element, what we need to do is the current value plus the previous value of prefix sum. So current of original plus previous of prefix sum. So now current of original, that is 3, plus previous of prefix sum, that is 1. So we would be writing here 4. Then we would be coming at this position. Current of original 5, previous is equals to 4, 5 plus 4, 9. 2 plus 9 is equals to 11. 2 plus 11 equals to 13. This is how you would get the prefix sum. Now, prefix sum allows you to calculate answer the queries in constant time. How to do it? Suppose we want the sum from this position to this position. So what we can do is, we know that the prefix sum is storing the sum till this point. So we would just take 11. Then we would subtract the unwanted part from it. So we would just subtract 1. That is, the value would become 10. Yes, 3 plus 5 plus 2 is equals to 10 itself. That is how the value is 10. Okay. So what we need to do is, if we are given L and R, okay, if we are told to find the range sum from L to R, what we would be doing is prefix of R minus prefix of L minus 1. Why L minus 1? Because if we want to calculate the sum from this to this, then we would be first having the sum till this point. Then we would be removing the outward, unwanted thing. So unwanted would lie beyond, no? Unwanted won't lie between this. Okay. Now let us implement prefix sum. So prefix sum is very easy to implement. So now just the intuition why we are copying the first value. So because for the first value, the sum till this point is the same element itself. So now let us implement this. Okay. So now what we can do is we can have a prefix sum of n, and then we would just have p of 0 is equals to 0. Okay, p of 0 is equals to 0. Then what we do is for loop in I is equals to 1, I is less than n and I plus plus, then p of I is equals to p of I minus 1, previous of the prefix plus the original plus the current value of the original. Now the prefix sum is there. Now what we need to do is we want the sum from L to R. So if we are given L and R, what we can do is p of R minus p of L minus 1. But there is a problem here. Suppose L is equals to 0. Then L minus 1 is equals to minus 1, and this would definitely give you an L. So what you can do is you can have something like this, that in sum is equals to p of R. Okay, p of R. Next, if L is greater than 0, then sum minus is equals to p of L minus 1. So if it is feasible, then only subtract the sum before it. If it is not feasible or there are no elements, then don't subtract the sum from this point. So quickly tell me if things are clear till this point or not. I would be waiting for the next 1 minute, next 30 seconds, and then I would turn on. Then I would move forward. Quickly tell me if things are clear to you or not. If you're not able to understand, just mention the line number and I would be more than happy to explain you. Okay. Okay. Now, clear bye. Thanks a lot, Harsha. Michael, thanks a lot. Selva, thanks a lot. Okay. Everyone is clear. So now we can say that we can do this. Now these things are very much clear. We can consider every index. Then we can go from L to L. But while looking at the editorial, I found a little bit different idea. The different idea is such that what we are doing is, so what is prefix sum? Prefix sum is calculated, 1 is copied, then 1 plus 3, 4, 4 plus 5, 9, 9 plus 2, 11, and then 11 plus 2, 13. So 1 plus 3, 4, 4 plus 5, 9, 1 plus 2, 11, 11 plus 13. Now, what we can do is, this is the prefix sum. So instead of having a query over L and R, you can do that. But there is one more idea towards it. We can have the suffix sum also, so that we don't need to query L and R. Okay? The suffix sum would be the same. If we are calculating the suffix, the first suffix element would be the same, that is 2. Then this would be this element plus this element, that is 4. Then this would be 4 plus 5, that is 9. Then 9 plus 3 is equals to 12. And 12 plus 1 is equals to 13. Now, the suffix would tell me the sum from this side and prefix would tell me the sum from this side. So now I would be standing, suppose I am standing at the third position because third position is the answer. So I can say what is the suffix value till this point. The suffix value is 4 and the prefix value is also 4. So sum before that and after that both are same. That means that yes, the value is equal. So now we will do the same thing for 2 itself. So the suffix prefix value is 9 and the suffix value is 2. 2 is not equal to 9, so it is not the value of itself. So that is how we can say that yes, building a prefix and suffix is also feasible, and you can directly build up a prefix sum and then query for L2. So how are you assigning PR to sum? R is not initialized, right? See, I'm not going into initialization or something, okay? Because, see, at this point, we are given a function. So, I just want to save time on implementation or something. That is why I'm not doing that for that kind of implementation. Assigning PR to R is not initialized. R is initialized here, by the way. See, int L comma R. I just wrote L is equals to 0 to tell you the bug. But if you don't consider it, then it is declared. But I'm not focusing on declaration, to be honest. I'm only interested in the implementation. I know you can initialize alphabets. That is why you are here. So I know you can initialize variables on your own. Okay? Fair enough? We would be moving forward. Okay. That is why we can say that the prefix of this is equal to suffix, then only we are returning I, else we are returning minus 1. I hope I am clear. Now I would be waiting for the next 1 minute and then we will be moving forward. This is an open forum now. You can ask me anything. Sir, please again explain prefix and suffix logic to solve the problem. So prefix and suffix logic is not very much different, because what we are doing is we are just coming from the back and we are coming from the front. So just build up the prefix and the suffix. Now what is the logic? See, prefix sum would tell us the sum from start to this point. Suffix sum would tell us the sum from end to this point. So we want only that only, na? That is why if you are standing at here, then if we go and find the prefix sum, it would tell us the start from this point, start from this point, end to this point. Suffix sum would tell me. So right can be handled by suffix, so suffix, left can be handled by prefix. Hope I am clear. Michael, am I clear or not? Quickly tell me. If I'm not clear, I would be more than happy to explain you again. Yeah, we are comparing the array of both. Yeah, please see the code. Please see the code, what we are doing. See, building up the prefix sum and suffix sum is absolutely the same. Okay. Now what we are doing is, if prefix of I is equals to suffix, then we are returning that. Showed you the dry run also. See, prefix this, suffix this. This 4 is equals to this 4. then they are equal. Yeah, sure. See this. If you want, I can code it right away from the very scratch. I'm more than happy to do that. Okay. Okay. You're most welcome. You don't need to say me thanks. If you want to say me thanks, what you can do is you can just add a small comment there so that the reach of this video would be more. Okay. Fair enough. So there are M job applicants and N jobs. Okay. The job applicants means there are N candidate and there are N jobs. Candidates and jobs. So each applicant is a subset of jobs. Subset of jobs that is she is interested in. Now we know what is subset. Okay. So that means that they have a proper some number of jobs with them that they think they are interested. Each opening can only accept one applicant. Okay. So we engineering college has a thing na, that one job, one candidate. Okay, one candy. I would just write candy because it is more funny. Okay. So yes, by the way, we have engineering colleges, we have this no, rule that one candidate, one job. Here it is one job, one candidate. Okay, fair enough. And each job applicant can only receive one applicant. A job applicant can be appointed to only one job. Same vice versa. Okay. We are given a matrix where I applicant is interested in the jth job. Okay, I and j. So this is the first row, this is the first row, this is the second row, and this is the third row. We know that. So now let us draw the diagram. So I applicant here I would write app here, and I would write here job here. Okay. So see, the first applicant is interested. So job are 1, 2, 3, 4, and 5. These are the job. And the applicant are 1, 2, 3, 4, and 5. So now the first applicant is interested in the job 1. So the first applicant is interested in the job 1. Then he is also interested in the job 2. Then he is also interested in job 4. Then he is also interested in job 5. Then we come to 2. 2 is not interested in 1, but 2 is interested in 2 itself. Then he is also interested in 5 itself. Then we come to 3. 3 is interested in 1. 3 is interested in 2. 3 is interested in 4. And 3 is interested in 5. Okay. There are 3 applicants with 5 jobs. Okay. So M job applicants, the M value is 3. That is why we don't require this 4 and 5. The number of jobs is 5. So now we can say that 1 can take the job 1. So 1 can take the job 1. Okay. So now 1 is fixed. So now we need to see for 2. Yes, 2 has a connection with 2 also. So we can say that 2 would take the job 2. And then we would come to 3. 3 would come first to 1. 1 is booked. 2 is booked. And then we come to 4. 4 is not booked. So we would simply say 3. Your applicant is 4. That is how the output is equals to 3. Can I have a quick yes or no if this sample test case is understood or not? So quickly tell me if things are clear or not. Okay, Michael, thanks a lot. What about Harsha? What about Selva? What about Devapriya? They have all gone. Okay, thanks a lot, Conan. Okay, thanks a lot. Thanks a lot, Harsha. Thanks a lot, Rohit. Thanks a lot, Selva. Selva, I was missing you. Okay, fair enough. Now, the first thing you should do is see. The first you should think about brute force approach. Then you should try to optimize it. This is what we generally do. So we can see that we would first go and see for one what are the jobs that are available to him. So let us go to his preference. The preference of one is 1, 2, 3, and 4. So we have 1, 2, 3, and 4. So we go to 1. So initially 1 is free. Okay. So we would go and fix 1. Then we would go to 2. Now 2, 1 is already fixed. 2's preference is 2. So we would go to 2. Yes, 2 is free. Let's fix it. Then we would go to 3. 3's preference is 1. Already fixed. Not possible. 3's preference is 2 also. Already fixed. Not possible. Then 3's preference is 4. So 4 is still not taken. So we would take that 4 also. And we can say that yes, we can do this. But what we are doing here, for each job applicant, for each candidate, we are iterating on all the n jobs. We are doing this. We are doing this or not? So for one applicant, we are hunting n jobs. So this is just like the idea that we start off from the available jobs. We suppose there is a preferred job in your side. So what you do is you go and see wherever the slot is empty, you sit there. The same idea can be thought of here. That the first we would need to iterate on all the jobs. If there is a place that is empty and it is our preference, then we would sit there. This is what we would do, na? We would do the same thing here also. So for one job applicant, we are hunting n jobs in the worst scenario. So for for m applicant, so multiplying m on both sides. So for m applicant, we would be hunting n into m jobs. So n into m, let us see the values of m and n. So m and n, if you go and see this value, that is m and n, that is 100. Okay, this is feasible. So the value of m into n. So we know that the time complexity of our solution is m into n. So we can say that 10 to the power 2 multiplied by 10 to the power 2, which is equal to 10 to the power 4, which is less than 10 to the power 8. So if we can do this, then we would not get a TL, not TL. This would give you, this would be within the time limit. Time complexity of brute force. This is it. If there are two applicants for who is the priority? If there are two applicants for a job. So if there are two applicants for a job, we don't need to care much. Why? Because what we can do is, this is 10 to the power 4. Okay. So we can try all possible combination. We don't need to go with this priority thing, because this priority thing would go to the max flow problem. But see, 10 to the power 4. So even if we try all possible combination, then it would be 10 to the power 2 again. 10 to the power 2 again. Why 10 to the power 2? Because first we can take one element priority and one second element priority. First element priority, second element priority. So we don't need to see, because that is the problem, that whichever has the maximum number of options, it should be considered last, and whosoever has less number of preferences, he should be preferred first. But that is a completely different problem as the constraint, if the constraints were tight. But we can see as the constraints are quite less, we can move forward with looking at all dimension. Am I clear or not? Just send me a quick one. That why this brute force would work. Even before implementing, why this brute force would work. Quickly tell me, send me a one in the chat. Why this brute force will work? So at the moment there are 26 people. So may I have a quick like from everyone? Quickly like this video, and if you're watching it offline, quickly comment in this video. Okay, do both. Okay, thanks a lot, Michael. One more person, and I would be moving forward. Just one more person. Quickly tell me a one, and I would be moving forward. Quickly. One more person, tell me a one. And if you're not understanding, send me a zero in the chat. Thanks a lot, Devapriya. Okay, fair enough. Now, how to do this? So we can say that this is a given matrix. So we can go here and we can search for all this. So we just need to traverse. We need to traverse. Now there are two possible traversal techniques. The first one is DFS, and this is an unweighted graph. And the second one is BFS. So DFS is a recursive implementation, and the implementation of DFS is very small. So the implementation of DFS is such small that we can do this. Okay, sublime text. Okay, suppose it is a traversal technique. If it is if it is a simple traversal, it won't return any value. We can write here DFS. We would get the source, and then we would mark the source as visited. The same thing we would do here also. Whenever we took up a job, we would mark it visited. Then we would go to the neighbors auto E of graph of the source. Then if the visited of E is not true, that the neighbors of the particular source is not visited, then we would do DFS of E. Fair enough? And this is the whole code of this DFS thing. Okay? Hope I'm clear? Okay. So now we would use the same scenario here also. I would just tell you what we are doing. We are first taking out the value of M and N. Then what we are doing is we are having a size N. Why? Because if we just take the maximum size, this would be, well, we don't need to worry about it. Because, so now we have the answer itself. Next, we need to try I and J. If it is possible, we would answer plus plus. Now what is this all about? So now we go to V is equals to 0 and we go on all the jobs. We iterate on all the jobs. If the job is a preference, so this is telling me what? That if preference, if it is a preference and it is not given, if this job is a preference and if it is not given, then we would take up this job. We would take up that job. And after taking up that job, if the value is less than 0, that it is not assigned to someone, then we would simply assign to someone. Then we would return true. This is what we are doing. If we are not able to assign, then we would return false. So if we are able to assign, that means one candidate is given a job. So we need to report the total number of candidates can be given a job. So yes, at each point we would be incrementing the count. So we are increasing the subspace. This is what we are doing. So just look at this one. Quickly tell me if this thing is clear or not. Just this part. Then we would move on to the next problem. I would have a timer here. This is the stopwatch. Quickly tell me if things are clear to you or not. So I have been speaking for the last 1 hour. So if you think that this is worthy enough, kindly comment it if you're seeing offline. Can we optimize it? Can we even optimize it? Yes, we can optimize it. Then we can need to use max and min flow. And we can optimize it very easily. Not easily, it is advanced algorithm. But if we can accommodate the solution in an easy way, if the brute force is passing, then why to implement the most optimized one in a lengthy manner and get a lower rank. Because if the given limit is 1 second, then there is no points if you submit the most optimized one. The person who submits the first would be assigned greater value. Yes, we can optimize it. Okay. Am I clear till this point or not? Can I have a quick yes or no? So am I clear to this point or not? Okay, Michael has replied. I'm waiting for the reply of others. Quickly send me a one if you have understood. I'm still waiting for you. As the number of people are also large, so I need to wait. There are 26 live viewers at the moment, and only one has replied. So kindly have some water. Yeah, thanks a lot. Okay, so what about others? Others have been there or not? Quickly tell me. Quickly tell me if I'm clear or not. Okay, so as 2.5 minutes have passed and no one is replying, it is kind of very depressing to see that. So I would be kind of moving forward, okay? So I won't be waiting and depressing myself. It is not the most optimal thing you should can do. Okay, so I waited for very long. So now this problem requires a bit of understanding of dynamic programming. You need to know dynamic programming to do this. So dynamic programming, recursion and dynamic programming is a prerequisite of this problem. I would just mention the prerequisite. Prerequisite are recursion plus dynamic programming. This is a prerequisite here because I can't start teaching you recursion and dynamic programming in this. I tried to cover all the prerequisite, but in this problem, this is not feasible. I hope you understand. So it is a one dimension. So there is given a one-dimensional garden of length n. And each position of the length n garden, a sprinkler has been installed. So given an array A such that AI describes the coverage limit of ith. So suppose we are given a sprinkler. Okay, it is sprinkling water in all directions. When will the next condition? Next Sunday. Suppose it is, sorry for this extremely bad handwriting. So extremely bad drawing. So now, suppose we have a sprinkler here. Okay, we have a sprinkler here. It is rotating and it is giving water in all the places. So as we are given an array like this, so we are only concerned about left and right because the up and down won't consider us because this is an 1D array. Okay. Fair enough. Now a sprinkler can cover max of I minus 1 and 1. So suppose this is 1, 2, 3. So this sprinkler can cover minus 1. So 1 minus 1 is equals to 0. But there is no index 0 because it is 1 index. So max, if it is less than 0, then it would be 1. Max of minus 1. So 0 and 1. Max is 1. So it would water from 1 till the index 1 plus a of 1, min of a of 1 and n. So 3 and 2. So the value would be 2. So it would water from 1 to 2. Okay. This is the scenario. Fair enough. Now we move forward. In the beginning, all the sprinklers are switched off. Every sprinkler is switched off in the beginning. The task is to find the minimum number of sprinklers that needs to be activated such that the whole end length garden can be covered by water. So just suppose there is a lot of sprinkler there. Okay, rather what I would do is I would just copy this one and I would have it. Okay, so suppose there is given a 1D array. Okay, I would show you the diagram of this. Suppose this is the given 1D. Is given like this. Then you are given sprinkler like this. So we are given sprinkler like this. Then we are given sprinkler like this. Then we are given sprinkler like this. Then we are given sprinkler like this. Basically, we are given sprinkler like this. And initially, all the sprinklers are switched on. And we need to turn on the sprinklers. We need to turn on the minimum number of sprinklers such that each part is being moved. Okay? This is what we need to do. Now let us see the first sample test case. The first sample test case is to turn on this water valve. If we water this one would also be watered, this one would also be watered. That is why only one is required to convert this. Yes, only one tap is enough to water the whole garden. Okay, fair enough. Now, what is the intuition for solving this? The first and the brute force approach. The brute force approach to this problem is that we consider all subsequent. Consider all subsequences. Now to consider all subsequence, there are 2 to the power n subsequences. Okay, if there are 2 to the power n subsequence, then the time complexity would be 2 to the power n. So what is the value of n? So the value of n is 10 to the power 200 into the power 5. So definitely it is much greater than 10 to the power 8. But how to find out all the subsequence? So to find out all the subsequence, we can use the idea of power set. Like if we have 1, 2, and 3, then we would go from 0 till 2 to the power n minus 1. Okay, so if 0, no bit is set, so we won't turn on any tap. So no tap is turned on. In the next step, 0, then we have 1. The binary representation of 1 is 1. So the last tap would be turned on. So the third tap would be turned on. Then we go to 2. That means 1 and 0. That means the second tap would be turned on. Then we go to 3. That means 1 and 1. That means 2 and 3 would be turned on. Then we go to 4. Then 1, 0, 0 would be turned on. That is only the first tap would be turned on. Then we go to 5. Then 5 is 1, 0, 1. That is first and the third tap would be turned on. Then we go to 6. Then is nothing but 1, 0. That is 1 and 2 would be turned on. Then the last part is 7. That means 1, 1, 1. That is all the taps would be turned on. So we can find out the number of taps we can turn on, and then we would just check by iterating over this that if it is sufficient to water all the plants or not. So we can use this power set thing to find the number of subset. After finding all the subset, we can use those subset to water the plants. I hope I'm clear till this point. Is this idea of power set clear or not? Yes, you can do that with recursion. You can do that using backtracking. Each step is accepted. But if you have an option to go with recursion or iterative, go with iterative. Because iterative does not uses stack space. Okay. Okay. Now we need to do better than this. Because if we do 2 to the power 10 to the power 10 to the power 5, then it would definitely explode. We need to do better than this. So how can we do better than this? We can do better than this by using this. That, see, the next tab should water more or equal. Why this is the scenario? Because see, Suppose the first tab is can water 1 to 3. So it can water 1, it can water 2, it can water 3. If this is the scenario, then the next tab should water at least 3, so that it would water this also, and this also. That is why the next tab should water more than or equal to. Okay. So now what we can do is we can do something known as dynamic programming idea to do this. Now there are two ways. Okay, there are two ways to solve this. There are two ways for consideration. If we see, we are going in two directions. Either we use this tab or we don't use this tab. Okay, and we need to go on both the direction. So as we are moving in both the directions, so this is not a knapsack problem. Okay, this is not a knapsack problem. So what we can do is, if we are using this tab, then we would be moving forward and updating it. So forward update. And if we don't, and if we are using this tab, then we would also go back. Suppose this is, so what is this, the meaning of this? And we would also update back also. So we would update the back and fro. So at each tab we would update back and fro. What do we mean by this? Suppose I have 3. So this is suppose 0, 0, 0. This is suppose 0, 0, 0. So if I am using this tab, then I can water this, I can water this, and I can water this. I can water this, I can water this, and I can water this. So if a better alternative is sitting at this position, I can consider him. Why? Because the elements which are in between these one are already watered by this element. The same goes for this side also. If a better candidate is sitting at this position, we can consider this. Why? Because the elements in between 3 and 5 is already watered by 3. That is what we can do. Okay, and this is the same thing we would do. And if we are, and at the end we would build up the DP array using this idea, and we would update the back and fro. Then we would kind of have the most optimal ones. Then we would see how many tabs do we really need to do. Okay, I would move to the implementation and it would be more clear. Trust me. So the implementation is like that. First, we find the left range. So this is just nothing but left range. This is nothing but finding the right range. So we are finding the left and the right range. Then we were doing what? I told you that we would update the back and fro. We would do the same thing. DP of left. DP of left is left range. First we would go to the left range, that is back. Then we would update the back side of it with that element or a better candidate. So current one can be the better or the last one can be the better. Okay, so that is what we can do. Okay, now we would initialize the count with 1, that we only need 1, and the next is 0, that yes, the next value is 0. Okay, then we would write, because we are using the first step itself. Okay, then the next is nothing but max of next one and DP. What is the use of this thing? I would be very well telling you this. Suppose the value is 1 and this value is 3. So we would be taking into consideration this value. So if we so what we would be there is, we would be having something known as next. Okay, if we are at this value, then we would consider this value. Why? Because this value can cover this also, can cover this also, and cover this also. So obviously taking 3 is much better than taking 1, because there is no priority that we would select a lower value of the tab and we would be having them. फिर से समझाता हूँ क्या कर रहा हूँ ना, डीपी अरे बिल्ड कैसे कर रहा हूँ कि पीछे जा रहा हूँ, पीछे जाके देख रहा हूँ कौन सा ज्यादा बेटर है, पिछला वाला वैल्यू या करंट वैल्यू, पिछला वाला वैल्यू करंट वैल्यू, वो तो हो गया एंड नीचे जाते हैं. नीचे जाने के बाद हम लोग देखते हैं कि कौन सा बेटर है, अभी वाला या जो अभी तक आ रहा है पीछे से वो बेटर है, कौन सा बेटर है. Okay, now translating the same in English, what we are doing is, how we are building the DP array, we are finding the left range and right range. Then we are saying that if the current range, if the current one is covering more, or the value we have updated long before is covering more, which is covering more, we are updating with that. by using max. Then we are coming to the number of tabs we need to use. So now, suppose we have a value 3 back and we have a value 1 now. So if we have that, then it is better to calculate then it's better to take the maximum one now, because there is no preference in taking either of the tabs. We just need to minimize the number of tabs. There is no preference or priority that take the lower value tabs or something. There is no preference. So if we take the higher value tabs, then it is more beneficial only, no? That is what we are doing. So if the range is exhausted, suppose this 3 is now there and we are now at this position. So if we are at this position, then we are resetting the value, we are increasing the number of tabs we need, because we know that to fill up this one we need one more tab. And then we are again updating this, because we know that this 3 range is now complete. Okay, now tell me if this thing is clear or not. Quickly tell me. I would wait for the next 1 or 2 minutes and then I would leave. Quickly tell me if things are clear to you or not. The 40 seconds is left. Please tell me if things are clear to you or not. At least say thank you if you have understood. At least. I have been speaking continuously for the last 1.15 minutes, and talking with your friends is very much different than speaking here with no one talking back to you. Can you please, what are you asking? Can you please join in? Yeah, why not? Let's do the join. And then I will leave. So see, initially all the values are -1. Let's do a join in for this only. So let's do a join in for this one. Initially the values are -1, -1, -1. Then we are coming to this value. This value can consider less than -1, the maximum of 0, or that -1. It is 1 itself. Okay. So we would take the maximum value. We would take that value. Then we would go on this side and we would take the maximum of it. We would take the maximum of it. If we are taking the maximum of it, this would tell me this position. Else, what we need to do is we would take up the next one. Okay? That is the next value plus the current value. So initially we would have this value. That is drawing of this is 0. Okay, 0 is greater than -1, so this will be updated to 0. Okay. Okay. Then we have the min of this value. Just a second. Okay. Please re-explain how you are filling the DP array. Okay, I will be now. So we have the left one, that is maximum of 0. Then we have the right one, that is array plus 1 and n. So we have the array of I plus 1, that is 0 plus 1 is equals to 1. So the maximum left, the left is equals to 0 and the right is equals to 1. Okay, then dp of left, that is 0. dp of 0 is equals to dp of left, that is -1, and right, that is 1. Which is better? 1 is better. That is how we are filling up this one. Am I clear? Okay, so I see no doubt coming in. re-explain DP array is done. Dry run is done for one index, and you can do the same for other indexes too. Okay, so that's it for today. I hope you have enjoyed. A lot of hard work has been put on this. So if you have seen till this point, consider sending a like and a comment. That's it for today. Thank you.